Well, thanks everybody. I hope you enjoyed the course that we just covered in the Getting Started series in computer vision. We covered a lot of ground and a lot of material at a pretty good level for a Getting Started series. And I think this is a good opportunity for us to talk with Dr. Satya Mallick, who's the CEO of OpenCV.org, to get his take on how do you get a job in computer vision, for example, and some of the other course offerings that we offer on OpenCV.org.
Thanks a lot, Bill. It's a pleasure to talk to this audience because they have just completed their first steps in OpenCV. And I can understand, it's very exciting. It's a very exciting field. And the next thing people ask is, how do you get a job in computer vision and AI? And the path is, you have to dedicate yourself. You have to commit yourselves to learning various aspects of computer vision. But there is a path through which you commit to that path, you will find a job at the end of this path. And as you know, Bill, your own journey is one great example of that. You started your journey in aeronautics and astronautics. You did your master's from MIT in that area. And for the longest time, you were in that area. But then you made a switch because of in your job, you wanted to use AI. But then gradually you made a switch to computer vision and AI. I would in fact love to hear that. We can start with that little story.
Yeah, sure. I mean, I'm excited to talk about that. So I worked in the space and defense industry for many years. Very rewarding experience. I loved the idea of space travel when I was a young child and ended up graduating with a degree in aeronautics and astronautics. And it was a wonderful experience for me. Along the way, I had the opportunity to work on a project that involved something completely unrelated to what I was doing. I was working, performing technical management on a project related to machine learning at the time. And this was about 8 or 9 years ago. And it was really exciting for me to see just how stunning the results were to some of these use cases that we were working on. It was a small research project, and shortly after that project, I began a journey on expanding my continued education. I studied machine learning and also image processing. And as I moved forward with that, I really felt a strong passion for working in the field of computer vision. So I spent quite a bit of time taking extra classes while working full time, early morning study sessions, and lots of weekends spent learning all this material. And I'm happy to say that I've landed in a very nice place, and I'm working in the field full time now, and I really enjoy it. Thank you.
Yeah, so that's, and you took deep learning with PyTorch, which is one of our courses as well.
Right,
and, right. So what I was saying is that there is a path. It's not necessarily easy, especially if you're working full time. You have to dedicate your nights and weekends. But there is definitely a path for people who are interested. And if you're a student, there is a very clear path, right? It's a relatively easy path. One thing I like to say, people, is that if you want to learn about physics, you have like 200 years of history in physics.
Right.
So you have to learn all that material to get started in physics, right? Before you can contribute in physics. But for computer vision, it's a relatively new field, right? Computer vision, you can say that even though research started in 1960s, it's really now that algorithms that work in the real world are available to the general public. So you're literally talking about a decade of worth of techniques, which is not a lot, frankly. So for people who are trying to start in this area, I would say that set aside, and especially people who are not doing it full time, they should set aside anywhere between 6 months to a year to learn the material, to get completely, and that's hard work, right? 6 months to a year of hard work, nights and weekends, to get their foothold in this field where you can think about making a career switch. There are other people in our courses who were able to make a switch by taking just one course. But I usually recommend that you need to understand traditional computer vision algorithms, and you also need to learn deep learning algorithms. So you need to have a flavor of both of those things. Let me actually start by explaining where what are the various aspects of AI, so that we lay out the land, and then it will be easy for beginners to understand what are the various topics we are talking about. Now, the first question people ask is, what is artificial intelligence? So it's a very fuzzy term. It doesn't refer to a specific technique, but in general, whenever we try to make machines think like humans, we call it artificial intelligence. And there are various ways of solving this problem. You can think about a rule-based system where you're encoding all the rules. Like in a chess game, you could say that, oh, if you do this, I'm going to do this step, right? And that used to be very popular a few decades back, but then people realized that you can actually train the machine by giving it data, not explicitly telling it, what the rules are, but it will automatically figure out things based on data. So that's machine learning. Machine learning is a subset of AI techniques where we care about data. The other part is deep learning. You might have heard a lot about this new kind of technique called deep learning, which is nothing but solving machine learning problems using deep neural networks. And in our course, we tell you why it is called deep. It's a very subtle thing, why it is called deep neural networks. But it is basically solving AI problems using neural networks. So that's deep learning. Computer vision is actually, there is an overlap of computer vision, deep learning, etc. Computer vision basically means the analysis of images and videos. And it is different from image processing, because in image processing, you have an input image and the output is also an image. You could be encoding an image, you could be enhancing an image, etc. So that all is under image processing. In computer vision, usually we have an input image and the output is information that we want. So the image could be this video session, but the output could be the faces that we detected, right? So it is image in and information out. Not only that, in computer vision, we also handle many things that have nothing to do with artificial intelligence. For example, in this course or in this video series, you learned how to create panoramas. That is a classical computer vision technique, and it has nothing to do with artificial intelligence, because you're stitching images together, you're using the geometry of image formation, you're using all these techniques, which are not really machine learning or AI, right? But they are still very useful techniques. So there is an overlap between artificial intelligence and computer vision, but computer vision does a lot more other things also. For example, the whole field of 3D computer vision, there used to be very little AI in that. Now, even AI is being used to enhance those fields also. So that's the general lay of the land.
So from the artificial intelligence standpoint, or the machine, computer vision is like machine learning for images is one way I like to think about that component of it. Yeah. And also image understanding is another way to think about computer vision, or the portion of it that's associated with machine learning and artificial intelligence.
Yeah, and there are other fields of AI, for example, natural language processing. That's another field where you deal with text data. We also have speech recognition, and that's another big field. For example, when you call Alexa, there is an artificial intelligence module that recognizes your voice, does the processing, interprets it, etc. So that's the speech processing. But among these different fields, I think computer vision has the biggest potential, because if you look at human visual system, it spends about 30% of its processing power on the visual part, because visual information is so rich. And we are also in a lucky spot that there are so many hundreds of millions of cameras in this world, which are continuously gathering data. So there is a lot of activity in the computer vision space. Even in aerospace, for example, for military and other applications, there are a ton of applications.
I mean, everybody's mobile devices, right? Everybody's mobile devices have cameras. So there's all kinds of video and image processing taking place. Yeah.
Yeah, and it's going to transform multiple industries. We are going to see in manufacturing, we also do consulting work, and we see people are using computer vision in manufacturing, in agriculture, in security, obviously in autonomous driving. That's a very big area. So computer vision is everywhere, and that's going to explode. It's already on the rise. There are so many jobs out there, and we will show you right there in the video. We will show you the pay grades of people who get jobs in this area. You can see that people make more than $1 million in companies like Facebook, etc. Of course, these are senior people, and these are level 6 engineers who who are accomplished. They are at the cutting edge. But it gives you a sense of an engineer is making. This is not like an entrepreneur, or this is not like a senior manager. This is an AI engineer making that kind of money in big companies. So that gives you a sense of why it is worthwhile taking a very hard look at these emerging fields as a career option.
So what about some of the course offerings? You want to talk about some of those? And
yeah, sure. So basically, before even we go there, right, it's instructive to know what are the things that you need to learn to get into the field, and what are the libraries you need to learn. So the very first thing is that it's very important to be very good at coding some of these algorithms, right? Algorithms are building systems. So you should be a very good programmer first, because this is a very engineering oriented field. You need to be able to write code. And Python is a great place to start, but don't end there, right? Learn as much as possible. If you want to learn C++, if you need to learn C++, learn it, and because it expands your chances of getting a job. So, but let's start with Python, right? Suppose you have Python expertise. What do you need to learn to get a job? First of all, as I said, that OpenCV is a fundamental library. You have to have good expertise in using OpenCV. That's number one. And then there are two other libraries that are very important. One is PyTorch, and this is a deep learning framework from Facebook. It's open source. It was developed at Facebook. And the second one is TensorFlow and Keras. So this library is developed by Google, also open source. These are all very good libraries. And if you have mastery over these three libraries, and you have mastery over computer vision and deep learning techniques, I think there is no way in the world you will not get a job. It's very easy to get a job once you have these 2 or 3 things under your belt. So from our course point of view, Computer Vision 1 covers traditional computer vision applications and not so much deep learning. We show you how to use deep learning in applications, but we don't show you how to train deep learning models. Computer Vision 2 is all about applications, and there we go over many different applications. We don't even worry about which library you are choosing. We expose you to several libraries that will allow you to you just build your arsenal of techniques and libraries and tools that you can use to build real world applications. And the third course is deep learning with PyTorch, where you go over the fundamentals of deep learning. And it is taught using PyTorch. And by the end of this year, 2021, we will also launch deep learning with TensorFlow and Keras. So basically, it's all covered. Anything related to computer vision that involves deep learning, it's covered in these courses. We go over image classification, object detection, image segmentation, pose estimation, etc. But these are very meaty courses in the sense that we go over all the theoretical details. You will learn about what is backpropagation and things like that. So once you take these courses, I think it is equivalent to getting a master's in computer vision and machine learning. You will get that level of knowledge. In fact, I can very easily say that by the time I completed my master's, I did not have this knowledge that people gain by taking computer vision 1 and deep learning. Let's say, even if you take these 2 courses, computer vision 1 and deep learning with PyTorch, I did not have that knowledge after my master's, right? So, and I can say that without any hesitation. These are solid courses. We took the best from various things. We are also very industry oriented, right? We are very applications oriented. So we picked the topics that are actually used in the industry and left out the things that are only of theoretical importance.
Right. So what about the prerequisites people might be wondering about? What's actually required to get started, and maybe what are the potential learning tracks here with 3 or 4 courses that we offer?
Yeah, so the prerequisite is just, intermediate level of knowledge in the Python programming language. Once you have that, you don't need any other prerequisites. But if you're starting, you've never tried OpenCV, you're just starting out, I would suggest that take our first course, OpenCV for beginners. And that is meant to be a quick, a very short and fun course. It is short, it is affordable, and it is something that you can try in a month. And that will give you an idea, do you actually enjoy building applications? Do you actually enjoy this field of computer vision and AI? Mm-hmm. And once you have completed that course and you're certain that you want to invest, time and energy into this field, then I would say that take Computer Vision 1, which is about classical computer vision. We also cover some deep learning, but it's very important to have the foundation ready. A lot of people I see, they directly jump into deep learning. That's also an option. But then what happens is that in real world, there are many problems that you don't solve using deep learning. It's just absurd to use that technique for solving some very easy problems in computer vision. And if you don't have that foundational stuff, you will try to look for a nail because you have this deep learning hammer.
Exactly.
Yeah. So, right. So that is a pitfall that people should avoid. So, Computer Vision 1 is the second one. You can also skip OpenCV for beginners if you're convinced that, you want to commit 3 to 4 months. You can directly take Computer Vision 1 and then take deep learning with PyTorch. If you have more time to invest, let's say you're a student, then you should definitely take the whole, 4 courses, or at least start with Computer Vision 1, Computer Vision 2, Deep Learning with PyTorch, and then when Deep Learning with TensorFlow and Keras comes along, that is also going to be very useful.
So Computer Vision 2, there's must be a little bit overlap between Computer Vision 1 and Computer Vision 2, but Computer Vision 2 is more application focused.
Yeah.
Is it considered a little bit more advanced, or what are the prerequisites for that?
It's not advanced, but we don't dive into a lot of theory in that. We are more interested in teaching people about the tools, right? For example, if we cover something like a barcode or a QR code scanner, we will tell you, this is the library, this is the best library to use for this application, but we may not go into how QR code is actually read, right? So we don't go into that level of detail. Similarly, we cover applications related to faces and face swapping and things like that. And in those cases, we go over some theory enough for you to understand, what's going on. But we may not go into the theoretical detail of, say, facial landmark detection, which can be mathematically challenging for people, right?
Right.
So yeah, so it is based on you build applications, right? That's the main focus. We will teach you how to build web applications, for example. So you get exposed to a wide variety of applications.
One thing that I noticed just in my own continued education in this area was that having a little bit of overlap is actually, I found it to be a valuable experience, because you might cover one particular topic in a class and then hit it again in another class, maybe from a slightly different perspective, or just the passage of time, and you're looking at the same topic again, several months later from a slightly different vantage point. I found is actually very helpful. So
actually, that's true about our deep learning with PyTorch and deep learning with TensorFlow courses as well. You may ask, if I have taken deep learning with PyTorch, does it make sense for me to take deep learning with TensorFlow as well? And the short answer is yes, absolutely. TensorFlow is the most popular deep learning library in the world, and PyTorch is the one that is rising the fastest. A lot of people like using PyTorch because it's very Pythonic. For Python developers, The learning curve is very, it's very gentle. You can easily pick up PyTorch. But when you go to the industry, right, you're looking for a job, right? You want to offer the best things you have. You cannot say, PyTorch is the library of my choice. I don't work in TensorFlow. Then people are not going to hire you, the people who actually use TensorFlow. As engineers, we should not be married to the tools, right? We are there to solve problems. And if taking this course, deep learning with TensorFlow, the theory is already covered in deep learning with PyTorch also. So there will be an overlap and there will be a repetition, but it will be in the context of a new course, right? So you are actually looking at from a different framework, right? TensorFlow is a different framework, and we are also adding new applications so that there is you get different applications with these two courses. But with, let's say, 30% extra effort, you learn a new framework, right? And now you have covered everything. With PyTorch and TensorFlow, you are all set in deep learning. And you also know the theory from when you take either course, we cover the theory that is necessary. So I think that what you said, it also is a revision of your theory when you take the second course. And people should not be married to tools. And I say this about other Python and C++ also. Python is definitely the first and the easiest language to get started with AI, but don't ignore C++ completely, because when you go to the job market, you may find that there are equal number of jobs in two areas, right? And you've already learned, you've done the hard work of learning the basics, the foundation, and now you're just worried about, I don't like this language or that language is hard. Language is just a way of solving problems, right? We should not be married to one particular language, because as engineers, we want to see ourselves as problem solvers, and whatever is the right tool for the problem, we'll use that, right? And two of our courses, Computer Vision 1 and Computer Vision 2, they are offered in both languages. In fact, when you purchase one course, the other course is for free, right? So now you can actually compare code side by side to see, oh, this is how it is done in C++ version of OpenCV.
That's really great. I like that feature especially. I think that's great. So we talked about Python versus C++ earlier, but I think some people might be wondering, obviously both would be good to have under your belt, but some people might be wondering to what extent is either language used in industry? And if you only knew one language very well, or you had an affinity for one of those languages for whatever reason, what is the market share for that language in industry?
Yeah, so Python is definitely, it is fast becoming the language of scientific computing. But then, there is, you can easily learn the concepts using Python, and it will also be, there are several jobs, there are large, I would say 50% of the jobs would easily take somebody who has Python skills. But then there is this whole other world of embedded computer vision, for example, where you're trying to do computer vision on really not very powerful devices, right? You're not using a GPU. Even if you're using a GPU, it's like an embedded GPU or something. In those cases, a lot of times these algorithms are implemented in C++, right? And sometimes even in C, right? In C, so that, because you don't have access to that much computational power. And that's a lot of, that's also a very big market. Think about all the security cameras, all kinds of devices which are embedded. I mean, if you love one language, Python is great. Try Python. You will gradually learn C++ over time. What I want to emphasize is that don't think that you're a Python developer only, right? Think about yourself as an engineer, and you will learn and whatever needs to be learned to make yourself fit for the job market.
All right, so one thing people might be wondering is there's certainly a lot of freely available course material on the internet. Universities are offering all their many top universities are offering many of their courses online for free. There's lots of tutorials. How do people sort this out, and what do your courses provide that maybe is not available online for free?
Yeah, so I actually encourage people to look at all the free stuff first, right? Because it builds their confidence, it builds the momentum. They start knowing what to expect, what they want to learn. So they start having an expectation what they want to learn. So by all means, there are a lot of free tutorials on opencv.org and also on learnopencv.com. Go ahead and try those. And there are several other very good bloggers also who you can try. Uh, and then there are free courses by universities as well. Try those as well. But then at some point, if you feel that you're missing a structure, sometimes what happens is that you take all these pieces, but you don't get a bigger picture. Pieces of computer vision, but you're not confident enough to go and present yourself in front of a job interviewer, because that you have learned in bits and pieces. You have not connected the dots completely, and that can be a blow to your confidence, right? When you take a course, it is structured, and that the important things have been covered. And suppose the interviewer asks you something which is beyond what you have learned, you can confidently say that, oh, I have not learned that, that's okay, but I know this thing. I have gone through a structured path to learn all these things. And in our courses, we also cover, there's a lot of code that people go through. You write a lot of code. I was saying that you need to be very good at programming. So you need to write a lot of code. You read a lot of code. So that's a very good practice. We also give you assignments and projects, and together that creates a sense of urgency. It creates a sense of responsibility that you have to finish this thing. What happens with online material is that you take this and you read the code, but you never write any code, right? You feel that you have understood it, but if you take away that code, you cannot ever write from scratch, right? You use that material as a crutch. So when you start doing something like a project, etc., it actually comes together, right? You feel you need to job market. It's basically a confidence game. You need to have your expertise to a level where you're confident you can face an interviewer, right? And then we also, not only that, on the internet, in a blog format, it is simply not possible to cover things in depth, right? So a lot of times people gloss over things, and we do that ourselves also. It's just simply not possible to go in a blog format. You have to condense everything to be easily consumable. You don't have that user for an hour, right? So you have to make sure that they learn whatever they want to learn in 10 minutes. And in doing so, the medium is restricted in some sense. So in courses, we don't have that restriction. We know that people are committed, they are ready to spend time on this. And so we take the time to explain in depth. That's a very important thing as well. And there is also peer pressure. When you see that other people are, asking questions in the course forum, they are enjoying the course, it puts a little bit of pressure on you in a positive way, which propels you that I also want to do something.
Well, you're all in it together, right?
Yeah,
it's a little
yeah.
bit of camaraderie too. And I think you said it perfectly, that confidence comes from mastery.
Yeah.
So you feel confident when you know that you've mastered one particular topic.
Yeah.
And then the other thing that you brought up is doing projects. So actually executing a project and taking what you've learned to create, an extension of that is, I think, very valuable, very rewarding. And also it forces you not to skip steps. So you could be reading a blog or watching a video online and nodding your head, yes, this all makes sense. But when it comes time to actually code something or create something a little bit different than what you learned, if you actually have to program it and get your hands dirty, it forces you not to skip steps or gloss over details that are actually required. So
Right.
I think that's a very valuable experience. So let's talk a little bit about what sort of jobs are available in industry. I mean, some immediate ones come to mind: the entertainment industry, perhaps medical imaging, manufacturing. But what are the different domains and types of fields where computer vision is actually being used more recently?
So Professor Andrew Ng, who is also the founder of Coursera, he likes to say that AI is like electricity. So when electricity was invented, it was used for lighting purposes. But within a few years, it transformed multiple industries. It was used in manufacturing, in agriculture, in a lot of different things. And AI has the same power, right? It is used in certain industries right now, but it is transforming multiple industries, including manufacturing, automotive, autonomous driving cars, and agriculture. We have a lot of people who are working on pest control, who are working on removing weeds in an agricultural setting. There are medical imaging is huge because now AI is doing better than radiologists in some sections, right? Because when the data becomes available and it's a repetition, some tasks which are repetitive, in those cases, AI is going to do better than humans over time as the data becomes available. It is those creative fields, let's say even in music and generating new images, AI is learning from existing data and creating new art form, right? But there are certain fields where AI is not going to take over. For example, comedy is one example. Comedy is you cannot train on comedy. If you if you look at the jokes that are produced by an AI system, they're usually pretty lame. They try to rhyme something because for creating comedy, you need things that come that's in that's not in a specific area. You could tell a joke which combines something going on in the music industry with something that is going on in sports, and when you put them together, it is funny, right?
Right. It's really hard how do you quantify that, right?
Right. And it's not domain specific because you took something very different in a completely different domain and combined it with something very different. And so those kinds of things which are one off, right? And it's even best comedians do not know what will fly, right? So they do a lot of tests themselves.
Right.
So those kinds of fields are very difficult, for AI. But everywhere else where it is very structured, like manufacturing, it's a very structured environment. Warehouses, it's a very structured environment.
A very controlled environment, right? So
yes,
a lot of variation is removed in those cases, so which makes it easier.
A lot of variations are removed, and they are repetitive tasks that can generate a lot of data, right? The key thing is that they are repetitive tasks. The same task is happening over and over again. No matter how complex the task, you can put a camera there and get as much data as possible as you want, and ultimately that problem will be solved, right? So if you look at all the companies, who are the companies hiring? When I graduated back in 2006, I had a few options. I could go to Microsoft Research, I could go to Google, I could go to a few different places. But now the people who come to us for consulting, they are all over the place. Obviously, these big companies are still there: Microsoft, Google, Facebook, Adobe. All these companies are still there who hire computer vision research engineers. But then there are small companies, one or like 5 people companies who are working on something very specific that you may not have thought about, but they need computer vision expertise. For example, one of the first consulting projects I did, they were sorting Lego pieces. So these Lego pieces, there are 10,000 of those. We don't realize it, but there are 10,000 unique Lego pieces, and they wanted to identify with reliability which piece it is, right? So because they wanted a replacement system that if some piece is lost, they can replace it. So you can see that is something that came out of the blue. I had never thought about, oh, that's an application area of computer vision, right? Another one was there is a company that is using computer vision for detecting the species of fish when they have, when they catch fish. They want to make sure just to, what is the size of the fish, what is the size, what is the species that they have caught, and things like that. So to do that analysis, they are using computer vision. Microscopy companies, we have worked on so many different applications, even applications which have a huge impact, like one where they were identifying shooters in school. And we had worked on a very proof of concept project with a company. And recently, a few weeks back, I came to know that they have grown into a full-fledged company and they are offering the service, right? So my point is that computer vision is everywhere. It's not just focused on these large companies, but I just gave you several examples. I'll add one more example. There is a company that used us for detecting fraud in fashion merchandise like bags. These bags are very expensive. Some of them are $2,000 for a small bag by a recognized brand. And they want to protect the brand identity. So they want to, something that is $2,000, you can make a very good copy of that for $1,000, right? And then sell it for $1,200 and still make a very good profit. So, but fortunately, these companies have very high standards, train a machine learning algorithm to know the difference between a fraud, a bag, and the real bag. So you can see now in the fashion industry, we have worked, and this is a small company, you know, I'm talking about a consulting company with 40, 50 people. We are receiving such a diverse set of problems to work on. We worked on sports analytics also, where we are tracking soccer ball in a sports setting. There are other companies who have approached us for baseball, for golf, and other projects like that one. So it's a very diverse range. We are lucky to be in this in this position. Where
I'm really curious that the example that you pointed to with the counterfeit merchandise, was that machine learning only, or did that incorporate deep learning?
It was a deep learning project.
It
was a deep learning project. And this company basically is in the business of selling secondhand. They buy these handbags and then resell them. So when they buy these handbags from people, they have to make sure that these handbags are genuine. And they have experts who go and check whether these things are genuine or not. And that requires a lot of expertise, right? Even to give a quote for this handbag, how much should it be quoted? You need to know the exact make and the model of the handbag, which is, there are 10,000 of these again, right? So you have to automatically determine, at least to get a ballpark, which kind of handbag it is. Otherwise, there are these experts who are, tens of experts who are employed just to look at these images and make sure that, this is this kind of handbag, right? This is a Gucci handbag of such and such model, and therefore it should be priced at such and such, right? And then the handbags comes in, and you have to determine whether it is counterfeit or not. And that requires a different level of expertise altogether, because mistakes can be really
expensive.
very expensive.
Right.
Yeah. They are putting their name on that this is a genuine item.
So we've covered quite a bit in this discussion today, and just curious if you had any final thoughts for people who are perhaps on the fence about getting into computer vision, or wondering exactly, how they might start.
Yeah. So final thoughts. First of all, don't be afraid of taking a leap into this field. The job opportunities are tremendous. It's a very good career switch for people who are interested. The first thing you have to answer for yourself is, are you interested in computer vision and AI? And if it, sparks joy in you, then this field is full of opportunities, high-paying jobs, etc. And take any learning path, right? It's not necessary that you take our courses, which you can, but jump into this learning path. Try to learn as much as possible from free material. And when you're ready, come to our courses. But even if you don't, it doesn't matter, right? The main important thing is that you embark on this journey, knowing that there are a lot of jobs available in this area. And if you spend about 6 months to about a year and dedicate your time and energy into this, you can become an expert, an engineer who can create, who can join this AI revolution. So with that in mind, I wish you all the best. Welcome to the AI revolution.